Imagine this. Apple spends billions of dollars designing its next iPhone. NVIDIA unveils the world's fastest AI chip. AMD announces a processor that could change gaming forever. The technology is ready, the designs are finished, the world is waiting, but there's just one problem. None of them can actually build their chips. Not because they forgot how, not because they ran out of money, because one company, one factory, suddenly stopped. Within weeks. Smartphone launches are delayed. AI companies slow down. Automakers struggle to get critical components. Stock markets panic. And governments begin emergency meetings, all because of a company most people have never heard of, TSMC. The company that quietly manufactures the future. When people think about the biggest technology companies on Earth, they usually picture Apple, NVIDIA, Google, Microsoft. They're the names on the products we use every day. But here's something most people don't realize. Almost none of those companies manufacture their own advanced chips. Instead, they all depend on one company. A company located on an island smaller than many US states. A company that rarely appears in advertisements, rarely holds flashy product launches, and almost never makes headlines. Yet without it, the modern technology industry would look completely different. This is the story of how one factory became more important than the companies it serves. Chapter 1. The Engineer. Nobody bet on every great company begins with an idea. TSMC began with rejection. Its founder, Morris Chang, had already spent decades in the semiconductor industry. By the early 1980s, he wasn't an ambitious young entrepreneur. He was a respected executive, after earning degrees at MIT and Stanford. Chang joined Texas Instruments in 1958. At the time, computers filled entire rooms, and semiconductors were still in their infancy. Over the next 25 years, he helped transform manufacturing inside one of America's most important chip companies. He became one of the industry's most respected engineers. Naturally, he believed he had earned the opportunity to become CEO. But that promotion never came. Someone else got the job. For many people, that would have been the perfect moment to retire. Instead, it became the turning point that changed the semiconductor industry forever. Shortly afterward, the Taiwanese government approached Chang with an unusual challenge. Help build a semiconductor industry from scratch, not in Silicon Valley, not in Japan, but in Taiwan. At first, it sounded impossible. Taiwan wasn't known for advanced technology. It had no dominant chip companies, no global reputation, no obvious advantage. Yet Morris Chang saw something everyone else had missed. Chapter 2. The Idea. Everyone thought would fail back then. Every semiconductor company followed the same formula. Design the chip, build the chip, sell the chip. Intel did it. Texas Instruments did it. Motorola did it. Owning factories wasn't optional. It was simply how the industry worked. But Morris Chang noticed something strange. Every new generation of chip factories was becoming dramatically more expensive. Building one now required billions of dollars, specialized equipment, thousands of engineers, years of research. Soon, even successful companies would struggle to keep up. So Chang asked a simple question. What if chip companies stopped building factories altogether? What if they focused only on designing better chips, while one company specialized in manufacturing them? At first, the idea sounded absurd. Why would Apple, or NVIDIA, or AMD trust another company with their most valuable designs? Wouldn't that create enormous risks? Most people thought so. But Chang believed specialization creates excellence. Airlines don't build their own airplanes. Movie studios don't manufacture cameras. And chip designers didn't necessarily need to own billion-dollar factories. In 1987, that idea became reality. Taiwan Semiconductor Manufacturing Company, TSMC. Unlike every major competitor, TSMC would never compete with its customers. It wouldn't design processors, it wouldn't launch smartphones, it wouldn't build computers. Its only mission would be to manufacture the best chips on Earth. At first, few companies believed the model would work. Today, it's the foundation of the entire semiconductor industry. Apple relies on it, NVIDIA relies on it. AMD relies on it. Qualcomm relies on it. Even companies competing fiercely with one another stand side by side, inside the same factories, because there's only one thing more expensive than trusting TSMC, trying to replace it. Creating a new business model was one thing. Proving it could outperform the biggest companies on Earth was something else entirely. Over the next 3 decades, TSMC wouldn't just build better factories, it would build the most advanced manufacturing facilities humanity had ever seen. Facilities so precise that a single speck of dust could destroy millions of dollars worth of chips. And that is where our story becomes truly unbelievable. Chapter 3. The most advanced factory on Earth. Building the world's best chips isn't just difficult, it's one of the greatest engineering challenges humanity has ever attempted. Walk inside one of TSMC's fabrication plants, and the first thing you'll notice is what you don't see. No dust, no noise, no workers rushing around. Instead, robots quietly move silicon wafers from one machine to another, 24 hours a day. The air is cleaner than an operating room, not because people work there, but because the chips can't survive without it. A single particle of dust, too small for your eyes to see, can destroy an entire wafer containing hundreds of advanced processors. One mistake, millions of dollars gone. And that's before the real manufacturing even begins. Modern chips are built layer by layer, sometimes requiring thousands of individual processing steps. Each one must be almost perfectly aligned with the previous layer. The margin for error is almost impossible to imagine. Then comes the machine that makes it all possible, the EUV lithography system, built by ASML. If you watched our previous documentary, you already know this machine weighs more than 180 tons, costs hundreds of millions of dollars, and uses light generated from droplets of molten tin. But here's what's fascinating. Owning the machine isn't enough. Anyone with enough money can buy equipment. Very few can master the process. That's where TSMC became different. Over decades, its engineers learned how to manufacture chips with astonishing consistency. Not once, not twice, but millions of times. That knowledge can't simply be copied, it's built through experience, failure, and years of relentless improvement. That's why companies like Apple, NVIDIA, AMD, and Qualcomm don't just trust TSMC's factories, they trust the people inside them. Chapter 4. The Island That Powers. The world Taiwan isn't a large country, yet every day, its factories manufacture the processors powering much of the modern world. Think about that. The smartphone in your pocket, the AI model answering your questions, the servers running cloud computing, the graphics card inside a gaming PC, many of them began their journey inside a TSMC fabrication plant. This concentration of manufacturing created something economists call the silicon shield. The idea is surprisingly simple. Because Taiwan has become so critical to global semiconductor production, every major economy has a powerful incentive to keep those factories running, not out of generosity, out of necessity. If production stopped for an extended period, the consequences would spread far beyond the technology industry. Car manufacturers would struggle to obtain essential chips. Medical equipment could face shortages, AI development would slow, supply chains across multiple industries would feel the impact. That's one reason governments around the world have invested heavily in expanding semiconductor manufacturing. TSMC itself has begun building new facilities in Arizona, Japan, and other regions. Not because Taiwan is becoming less important, but because the world has learned a difficult lesson. When one company becomes this essential, everyone wants a backup, even if replacing it isn't realistic. Chapter 5. The race beyond silicon technology never stands still, and neither does TSMC. While the world celebrates today's breakthroughs, its engineers are already working on tomorrow's. Every new generation of chips is smaller, more powerful, more energy efficient, but shrinking transistors has become incredibly difficult. Every advancement now costs billions of dollars, requires years of research, and depends on partnerships with companies like ASML, Zeiss, and countless specialized suppliers around the world. This isn't just a race between chip companies anymore. It's a race to define the future of artificial intelligence, the future of medicine, the future of transportation, the future of scientific discovery, and every major technology company knows it. That's why the demand for TSMC's manufacturing capacity continues to grow, because no matter how brilliant your engineers are, a chip design means nothing until someone can actually build it. History often remembers the companies that launched the products, the iPhone, the RTX graphics card, the latest AI model. They're the innovations people can see. But behind almost every technological revolution, there's another company, working quietly in the background. TSMC doesn't create the products we line up to buy. It doesn't design the processors that dominate headlines. Instead, it does something arguably even more important. It turns impossible ideas into physical reality. Every breakthrough begins as a concept, a blueprint, a design. But until someone manufactures it, it's just an idea. For decades, TSMC has been the company transforming those ideas into the chips powering our world. Perhaps that's why its influence feels almost invisible. Not because it isn't important, but because its greatest achievement is making everyone else's innovation possible. Sometimes, the companies shaping the future aren't the ones standing on stage. They're the ones building the stage itself. Outro. If you enjoyed this documentary, consider subscribing to Foundry. Every week, we explore the hidden companies, the overlooked technologies, and the decisions that quietly shaped the modern world. Because once you understand what's happening behind the scenes, you'll never look at technology the same way again. Until next time, thanks for watching.